Thank you very much. So welcome to the next in a series of Future of Games presentations. Today, we've got a great speaker. I'm really excited to introduce her. But first, I want to mention that for more information about this speaker series, you should go to the DGRC website, which is dgrc.ncsu.edu. And you can subscribe there to talk announcements so that you can get updates for all the future talks as well. Today's speaker is Lynn Walker. Lynn is a professor at the University of Sheffield's Department of Computer Science, where she directs the Cognitive Systems Group. Lynn has a very distinguished career in working in conversational agents. Before coming to Sheffield, she was a research scientist at Hewlett-Packard Labs and at Mitsubishi Labs Merle in Boston, and also at AT&T Bell Labs. With that, I'll let Lynn get started. Okay. Thank you very much.
Thanks. So I want to talk today about some ideas that are kind of closely related to a lot of the stuff that you've been doing here in the games, development area, and I hope maybe we'll have a chance to talk more afterwards about kind of some other links between our work. I just want to start off saying that my primary focus in research is not just dialogue in computer gaming or interactive drama systems, but dialogue in general, and I have a really deep interest in dialogue because conversation is the primary means by which humans communicate beliefs, intentions, desires, emotions, attitudes, and their personality. And the idea of being able to have a very flexible dialogue facility in games or interactive drama systems is that dialogue can support player agency and it has to do with the way that the plot is communicated in story systems and especially in social games as well. And there's studies that show that having a good dialogue component as part of an interactive drama system engenders perceptions of high interactivity and immersivity in the game. And I think that if we evolve the ability to support natural dialogic interaction, it's going to lead to new kinds of games and a new conception of what games could be. So if you kind of look at, this is a very rough cut state of the art, so I hope I'm not going to insult anybody with, with this, but if you look at dialogue in games, if you look especially at commercial stuff that's out there, you have any kind of dialogue you have is supported just by a simple kind of dialogue tree mechanism, which is like a finite state machine. And sometimes the user's participation in the dialogue just consists of selecting from a fixed path, from an utterance that's been already handcrafted and encoded in the system. So that's the level of the user's interactivity. And if you go like expand that a little bit and you allow the user to put in any kind of natural language utterance, which you then classify into one of these preset types, which is what was done in Facade, you get much more perception that you're having a dialogue, even though it's not a massive expansion of the underlying capability of the system. You still have fixed paths that you're following through. And one of the limitations of this is on the so you get more flexibility on the input side, but on the output side, you still have all the utterances are handcrafted and recorded. And then more recently, mostly in the kind of training area or learning systems, there's been much more attempt at having a full-fledged dialogue capability where you could have speech in and text-to-speech out. For example, in the Tactical Iraqi system, which won an award at the Serious Games Conference, it's actually built on top of a dialogue architecture, and it has full speech recognition component. And there's been some more work in that area more recently about information gathering. So again, this is for military applications, but a lot of people here have looked at some of these same things for tutoring applications. And the challenges with trying to put dialogue, some kind of dialogue into a game system are similar to most other kinds of things you're trying to do. There's a whole problem with author control, where the author wants to define how the story is going to evolve, but you also have a tension with that, with the player agency, the player feeling like they're having an effect on what happens in the system. And you need you need strong plot structures to kind of make sure that things happen and that the story has meaning. But you also want to be able to support multiple storylines in the replay of the game. So from the engineering side, which is kind of where a lot of my focus has been, the authoring and the handcrafting that is involved with trying to support multiple storylines is very costly. And if you use these state machines to represent the flow of the dialogue, you have lots of problems ensuring consistency in all the paths through the state machines. And you also have problems in maintaining and extending these highly handcrafted systems. So if you want to add some new path in, you have to worry about its interaction with all these other paths. And these challenges, what I find interesting is that these challenges are exactly the same that you face if you use these kind of architectures for task-oriented spoken dialogue systems, like the work that I did at AT&T. So if you look at the evolution of the architecture for task-oriented spoken dialogue systems, you have speech recognition in and text-to-speech out, and you can have just not speech in and speech out, but you can have gesture in for a multimodal system or pointing, and you can have animation or an embodied conversational character out, or you can just have a text-based dialogue system where you get rid of this component. But the issue that I want to make an analogy between is that this area, and kind of led by the speech community, there's been a huge focus on empirical work in this area and data-driven methods, to the point where, like our text-to-speech engine that we developed at AT&T, all you have to do is collect a corpus of utterances and their recordings, and then everything happens automatically, the alignment, the phonetic segmentation. So basically, it's a kind of push-button system. You go out, you get some voice talent, for a particular domain, you record the voice, producing a bunch of things that you think the system's going to want to say, and then you just kind of press a button, and you've got a text-to-speech engine for that domain. And I'm sure you're all familiar with the way that ASR works. You get more and more data, you get better performance. It's all data-driven. But when you look at what's been done in the dialogue management and spoken language generation components, it's remained highly handcrafted. And just like in games, these components in all the commercial systems that are out there are handcrafted and usually recorded by voice talent. So the people that are developing the user experience for, like, Tell-Me's directory lookup systems are spending weeks and weeks and weeks kind of carefully crafting and re-recording the system's persona, how it projects itself. And it's very costly. It really limits how many systems can be built. So you can't just roll out systems in a new domain very easily because of this handcrafting problem. So there's this strong link between my work in this area trying to look at games and also what's going on in task dialogue systems. And there's many of the exact same issues. And I think there's a lot of benefit to be gained by looking at the literature across those two areas. So what we've been arguing in both of these areas for about 10 years now is that spoken language generation can offer part of the solution to this engineering problem. Because you can get quality system output with less handcrafting, so we believe it's a way to kind of solve at least some part of the problem with the authoring bottleneck. And it also gives you portability and customizability to different domains, applications, and user groups. And if you use trainable methods in language generation, you get these big benefits of automatically being able to do kind of personalization to individuals, which there's no way you could ever do that with a handcrafted system. You just can't build a different system for each person who might use it. So the work that we've been doing has been drawing on theories in social psychology and sociolinguistics. We started off looking at politeness. There's a theory of politeness shown here by Penelope Brown and Stephen Levinson, and this is not about saying please and thank you. It's called politeness, but it's about, the basic idea is that you craft your utterances to reflect your social relationship with people that you're talking to, and to respect their right of being autonomous, of not having their autonomy impinged upon, and their feelings about wanting to have everything kind of be smooth within their social group. So things like if you want somebody to do something for you, you might simply produce an indirect speech act stating that you have a need for something or that some condition doesn't hold rather than asking them directly. So all of that indirect speech act work is kind of covered in this politeness framework. And so that's one of the reasons that we were interested in it. And the second area that we've been looking at more recently is using the Big Five model personality, which is what I'm really going to focus on today. But I just want to show you how we started this idea with the politeness stuff, and then we're assuming a similar kind of framework for personality, which is very similar to what Yoon Young and John were talking about me yesterday, what their assumptions are with respect to where language generation would fit in. So we're all kind of all on the same page there. So the basic idea is that you have authors or AI planners will provide a pool of content and a script for an interactive drama or a story system that's represented as a sequence of speech acts and domain actions. And this part should provide author control, because you can have it be automatically generated like in some of the work here, but you could have an author do it if you wanted, and you can have the author have a lot of influence on the or selection process on the plans that would even be generated by an automatic planner. And then the idea is that the variation in the script is provided by the generator output. So this variation can be driven by, it can model or it can react to the user's personality or emotions or the user's politeness. So that gives the player a feeling of agency. It gives the non-player characters an ability to kind of improvise on the original script. And as I said before, if you use trainable methods in this part, you can support personalization. And you can optimize the trainable method to any objective function that you want. So it can be aesthetic quality, or it can be learning, or any kind of thing that you want to optimize. So the first work that we did in this area was, we published it in some Lifelike Computer Characters workshop, but the first real proper conference publication was in Agents 97. And we represented a bit of a script from Casablanca, where Laszlo and Ilsa walk into Rick's cafe. And the basic idea was that you could take a script and you can represent it. This is just kind of the top level of the representation. You represent it as a speech act or a plan with speech acts like offer, request act, accept request, request act. And each of those would have content variables. And then the way that the Viva, this is virtual interaction with virtual agents, the way that this system would generate variations on the dialogue is that you would have a script with all these different speech acts represented by the players, the human player perhaps, or the non-player character, and you take the speech act type, you make some calculations based on your politeness theory, and you determine what kind of how you're going to realize that speech act. And we had Janet Kahn's master's thesis work in here where you could express emotion with a TTS engine. So we put those things together, and we calculated which strategy you were going to use to generate the surface form, and then we could enrich that with some kind of acoustical features from the text-to-speech engine and produce this utterance. And the kind of stuff we could produce, it was really exploratory. We didn't do any evaluation of this. But we're really interested in the fact that if we combine these different linguistic forms, like I think I've taken the example out, but if we combine different linguistic forms, like in that script, Laszlo asked for 2 Cointreau, and there are different forms for this, like if you have a form that treats the waiter as though they have a lot of power over the speaker, so that the interlocutor is framed as somebody who's got a lot of power and who's not likely to do what you want to do, then Laszlo might say something like, you wouldn't want to bring us 2 Cointreau, would you? And so he's suddenly transformed into kind of total wimp. And then if you put some of these other acoustic realizations with it, like disgust, which is one of the things that Janet had in her system, you get this really kind of sneering, sarcastic characterization of that character in that particular speech act. And we just felt that there was a lot of richness here that was worth kind of further exploring, what you could do with these things. And we didn't really have a good way to control it or to project what kind of character we were really doing, but we could see that there was a lot of richness there. And so that's why that's where I started with this stuff, and we tried to build on it since then. So there's been a lot of other work in this area, and I can't really talk about all of it. But basically, a lot of this work is kind of in the same vein. It uses some kind of AI representation, and then it has some kind of automatically generated variation. And it's been shown to not just engender a kind of rich characterization, but to have effects in task-oriented dialogues like learning systems, so that these choices of form have effects in places where you wouldn't think that they would, like they help learners learn better. You get an effect in learning, or they make people think that the system is more intelligent just because it happens to use a particular form. So those results are also interesting in terms of serious game and learning systems. And but again, a lot of this work has some limitations. So if you look, for example, at just one example of this inhabited marketplace work that was done by Andre, you have these 3 characters, and it's a kind of sales and marketing application where the characters argue about what the benefits are of certain products. And you can, in their demo interface, what you can do is you can choose a personality type amongst 3 types. So you can get different versions of the dialogue by selecting these different buttons. But what this does is that this sets flags in the script generation component that picks among a few predefined forms. So you still have this handcrafting here, where but it's kind of following the same basic idea, but it's not a rich generative component like you have with spoken language generation. So that's kind of the area that we're trying to address. And the basic idea is that this template-based generation, so in that marketplace example, the wizard says something like, forget the running costs, think of the prestige. And so, as I said, there would be these flags set for a particular personality type, and maybe if you thought the user was somebody that was really interested in status, you might say something like, forget the X. But if you think that the user is a kind of risk-averse person who wants to have a reliable economical vehicle, maybe you're going to say something instead like, I wouldn't be concerned about the X, right? So you just try to draw their attention away from it. And the advantages of template-based generation is that it's conceptually simple, that anybody who's a native speaker of the language can produce templates, which are basically strings with variables in it. And the disadvantages, which is a big problem, as I said, for commercialization of dialogue technologies in general, is that you start from scratch for every domain. You repeatedly encode linguistic rules. It's hard to get certain kinds of variation, like if you're just concatenating a bunch of templates together, you can't get good keyword placement because you don't have the representation at the right level. And you can't get this personalization thing. And as again, you have these engineering problems where we have these big databases of templates that you can't, if you try, obviously you can do anything you want. You can build a massive system that has a template written for every particular context and user, but then you've got a real engineering problem with maintaining it. And in the area of the personality work that we've done, when we set out to look at this, we found a lot of people had done some really interesting work with personality, including people here. But we found that there was this massive literature in social personality psychology, and nobody seemed to be drawing on those findings in the literature. So that was one of the first things that we set out to do, was to try to organize that, and I'll explain that in a minute. It also was kind of unclear which of these findings, like if you look at the work of Nass and Reeves at Stanford, it was all very heuristic. They used their kind of common sense notions of what it meant to be a dominant person, and they handcrafted utterances that expressed a dominant personality. Then they tested them with some pilot users to have the users say, yes, that's dominant. And then they would run a user study with those handcrafted utterances and test what the effect was on the user of having these dominant utterances. And so they had some nice results, but in terms of the underlying technology, nobody could kind of repeat what they'd done in a different domain because it was all based on their kind of heuristic gestalt of what it meant to be a dominant personality. And in general, there's been very little evaluation in this particular area showing that that the system produces some kind of variation that you intend to be perceived in a particular way, like as a bully character or whatever, and that indeed it gets perceived in that way. So in this personage work, we decided we would build on the big 5 personality traits, which are represented in psychological theory as scalar values, usually between 1 to 5 or 1 to 7, for these 5 different traits. And these traits are assumed to be normally distributed in human beings, and they're assumed to be independent. So there'd be very few people that would be at the extremes, and a lot of people are kind of in the middle on most of the traits. And I'll explain a bit more about this. So the idea is that you take a standard dialogue architecture, and we have some work on personality recognition where you might extract the personality of the user from what the user says, and then you use that to affect the personality of the system. Now, it's not clear, and we haven't done anything saying what that mapping is. We're just saying, well, we can recognize the user's personality, and we can use it to affect the system's output, but we're not making any claims about that similarity attraction is the right thing, that you would want to match the user's personality, or that, you know, opposites attract, or we're not making any claims like that. And so the basic idea is that we take the spoken language generation, the standard pipeline architecture, and that we are going to add in variation. Whoops, what have I done? Okay. So we're going to take the standard spoken language generation architecture, which probably most people here don't need to have this explain what it does. But at the top level, you kind of divide the system into what the character is going to say versus how they're going to say it. And here's a little bit more detail. I guess I should go this way since my thing is there. So there's a content planner which decides what information to communicate, and it selects content and it puts some ordering on the content. There's a sentence planning component that decides what words and syntactic structures will be used to communicate the content. And usually in this module you have functions for what's called aggregation, which decides for each proposition or set of propositions you want to express, whether they go in individual sentences or whether they get combined into one sentence, and what kind of structures will be used to combine them, and then which lexical terms that you use to express the relations and entities. Then you have a realization component that decides how it would all be combined into a sentence that's syntactically and morphologically correct. And the content planning, the sentence planning components might be language independent, and then your realization engine could be different for different languages. And then you can have a prosody assignment module that operates after that works on those representations to decide. And we wanted to stick in, as I said, we wanted to put Big 5 in here, and I just want to take a moment to say, well, why we think that Big 5 theory of personality is useful. First of all, it's been driven bottom up. It's a theory or an account of human personality that's been driven bottom up by descriptions of people. And it's been shown, therefore, to kind of capture human norms about perception of variation. So we think, well, if we're building on top of those human norms, like the theory of politeness, that we would be more likely to be able to directly affect users' perceptions of the characters. And there's all these studies that map personality factors to linguistic and paralinguistic behavior. There's also a lot of work that shows that personality has a biological basis, so that, for example, extroversion is strongly linked to dopamine, neuroticism is linked to serotonin, and that testosterone has a big effect on your aggressiveness, which nobody would find really surprising. And it also provides evaluation metrics. So there's all these psychologically validated instruments out there that you can use for evaluation that psychologists have already shown that these measure what you're trying to measure. So you get a lot of stuff kind of off the shelf. And as I said, this Big Five trait theory was developed bottom up. It started with this idea, this lexical hypothesis, which is that if there's an important trait, character trait, that distinguishes people, there will be a word for it in the language that describes that. And so the way that this stuff worked bottom up was that Allport collected something like 17,583 English adjective trait descriptors, and he asked people to describe themselves and describe other people they know, and then he did a factor analysis on those descriptions, seeing which trait characterizations factored together, and he found that there were kind of 5 major factors in there, and this has been replicated. This factor analysis has been replicated over and over again using different sets of trait descriptors. So there seems to be a lot of agreement in the psychology literature that there's kind of 5 big super traits, and there's other stuff going on as well, but these 5 big super traits explain much of the variation between people. So these traits are the big 5 are their conscientiousness, which trait adjectives that might be associated with those are kind of dutiful versus impulsive. So remember I said these things are normally distributed in the human population. They're scalar. They go from 1 to 7. So for each trait, we have a scale, right? So on the low end of the scale for conscientiousness, we would have impulsive, and on the high end of the scale, we would have something like dutiful, right? So we're talking about something that varies along a scale. Emotional stability is another one. So you can think of like Woody Allen. I have a hypothesis that all of our stereotypes about emotionally unstable people are emotionally unstable extroverts, because the introverts, they just keep their neuroticism to themselves, right? So you don't really know what's going on in their twisted little mind. So we have emotional stability, where you'd be kind of a calm person versus somebody that's anxious. Openness to experience is one of the most debated traits. So the Mad Hatter and Lewis Carroll would be the extreme end of this trait, somebody that's imaginative, spontaneous, a bit mad maybe, versus somebody who's kind of conventional and rigid. Agreeableness, be kind of kind, trustworthy, versus somebody who's unfriendly, disagreeable, critical. And extroversion, Bill Clinton is a great example of a wild extrovert. And each of these traits has a substructure on it, but this is kind of the top level. So there's been a lot of work in psychology, as I said, like over 50 years, looking at how these personality measurements along these big 5 traits correlate with different linguistic reflexes, which is why we thought it would give us something that we could build on. So this is some data from that Matthias Mell at University of Arizona collected. This is a study called EAR, which stood for Electronically Activated Recorder, and what he did was he got 100 undergraduates to walk around being constantly mic'd for 2 days, and every little interval it would capture a snippet of what they were saying, and then it would and then those recordings were all transcribed. They were all judged by observers as to what personality the subject was exhibited over the 2 days. And then they also had the subject self-assessments of what their personality was. So it's one of the few studies of data that's out there where you can look at how self-assessment differs from observer's assessment, and where you have data that's collected like in the wild, in the real world. And just so you kind of get a sense of the kinds of findings that we're trying to build on in psychology, here's this introvert. I just think I fixed this. Oh. Where's the volume control? Yeah, I did that. Yeah. This one is kind of quiet. Let me click the loud one while you're messing with that. So she talks a lot. She has a bouncy voice. I'm going to go back to this in a second. And this is the introvert. So these are kind of extremes on this. So that's the kind of data that the psychologists usually work with. And the kind of findings that they have are things like that extroverts, they talk more, they talk faster, they talk louder, they're more repetitive, with fewer pauses and hesitations. They use more they use more of the same words and not so many new words in their utterances. They're less formal. Their talk is more situated, and they use more positive emotion words. Neurotics use more first-person singular pronouns. They use more negative emotion words. Conscientious people use fewer negations and negative emotion words. And what they find on data like this is they'll find these very low but significant correlations. So they'd be significant, but the correlations might be as little as 0.05. So when we're looking at this, we're thinking, okay, it gives us some parameters that we might want to vary, but is it going to have any effect, right? That was our first question. And just to kind of go back to that snippet, you can see that some of the stuff that they're talking about is like this. You can see straight off that these utterances, well, first of all, there's the voice differences, right, which are big between introverts and extroverts. But you get these short utterances versus these long utterances. You get a big use of first-person pronouns where she's kind of talking about other stuff. Extroverts have a much greater need to talk than they have things to say. So they're redundant with what they paraphrase themselves. They go on and on, kind of thing like that. And they take the initiative more in conversation. So there's those are the kind of findings that we decided we were going to try to use. So the first step was to take all these findings from psychology and try to map those into the NLG architecture and implement some parameters that we thought would realize those findings. And we decided to do this because we already had a generator that produced recommendations and comparisons in the restaurant domain, and we had no better idea about what kind of speech acts might express personality. We decided just to build on this in this area. And we wanted to look at both rule-based and statistical generation. And then, as I said, we can evaluate this using standard instruments from psychology. So you're not supposed to be able to read this, but the basic idea here is that there's all these findings, and we're really surprised nobody had kind of organized them for us. We thought we could go and get somebody's related work chapter from their thesis, and we would just get this stuff, but nobody had done it. And so what this shows is that we have these NLG modules here on the side, like content selection, template selection, aggregation, and these transformations. And then here, like for introverts and extroverts, we have some findings from the literature, and then we have parameters that we hypothesized might be one way of realizing those findings in a natural language generation system. And if you look at the architecture, we found that those findings are spread across all these different modules. They're not just in one place. And so what we're doing, and this is just the very top bit of that big table that I showed you, which you can find in one of our papers. We have an NLG module like content selection. We have some findings from the literature, and then we hypothesize these parameters, and then we can take from the literature suggestions about where that parameter setting would be on a scale of 0 to 1. So most of the parameters are scalar. Some of them are binary. And the basic idea where I think is a big contribution that even if people don't like what we've done, they'd be able to build on is this organizing all this literature. So we have these very vague genre-specific findings for weak correlations. We have no idea what domains they apply in or whether they apply to domains. And we suggest that here's at least one hypothesis about a generation parameter, which is a way of realizing that finding that's in the literature. And when we put all these parameters into our generator, we can generate lots and lots and lots of variation given these parameters. And I'm going to try to get through enough of this I can show you what we can generate. But just here, are a couple of examples. This is on the extroversion scale. These are the mean ratings of judges. So these utterances generated by our generator go from introverted to extroverted. And we have all these different manipulations that we're doing that do some of those things like you saw in the naturally occurring examples, like the extrovert repeats himself here. He puts in paraphrases and stuff like that. They produce longer utterances. And I'll show you how that works. I'm going to skip through here because I'm taking a lot longer than I should. So the architecture is that you have some information about a restaurant that comes in, some propositions about a restaurant, say, for example, that service is a 6 out of 10 or a 2 out of 5, and then you have these generation parameters, and then you have all these different modules that manipulate the utterance to try to produce something that reflects a particular personality. And this interface is like what I talked about in the Viva, that we assume that the interface between the AI planner or the author and the generation system is at this speech act level. So in the first phase, we have a speech act that comes in, and we organize the data into a content tree, a content plan tree, and then we decide based on the input parameters, like whether you want to be an extrovert, for example, or an introvert, which content items we're going to select and how we're going to structure them and how we're going to aggregate them. So here's some examples. Like for the verbosity parameter, we decide how much content we're going to select. For the content polarity parameter, we decide whether we're going to select positive or negative content. We have this way of making the utterances longer, kind of with redundancy, by inserting restatements and repetitions. And then concession is a very powerful thing that you can do with positive and negative content. So you can produce an utterance that has both positive and negative content, like Walkmania has awful food, the food is cheap. And depending on how you structure those with a concession, you foreground the positive or negative content. So you can say, even if Walkmania has awful food, it's cheap, versus even if Walkmania is cheap, the food is awful. And the impression that the hearer is left with is very, very different between those two things. And that's just a simple manipulation of how you structure that information. There's all these different aggregation operations you can see, like if you wanted to make a contrast, for example, and you said but, versus on the other hand, that there's a big difference in formality that is coming through just from a choice like that. In the syntactic template selection, we have a dictionary where you look up these syntactic templates. So this part is handcrafted, these template, these dependency trees. But by having this tree representation, we can do a lot with it. And we have in other work looked at trying to learn the mapping between a propositional representation and a dependency tree syntax. And you can mine that from the tree bank or places like that. So there's a chance to get away from this handcrafting, although we haven't really done that. But it's at the very primitive level of the system, and everything else is automatically generated. So for like choosing different syntactic templates, we might have parameters come in like syntactic complexity, like introverts use more syntactically complex utterances and introverts use more self-references. So we might have a particular idea about what we want the template to look like, and we can automatically score these templates on all these different dimensions. And then what we do is we just pick the target that's the closest to the one that, so we have a target we want to hit. We might not have something in the database that exactly hits that target, but we can find the closest thing to the target. And we have all these pragmatic transformations, like the one I'm going to talk about is that you can change something like X has good food to X doesn't have bad food by using antonyms in WordNet, and you can insert all these different hedges and tag questions. Again, we think that it's important to have the dependency tree representation, because what RealPro lets us do is that when we want to do a negation, all we have to do is put negated true here in the feature representation, and then we change the adjective down here. We can localize those things. We're not doing string manipulations. And we haven't shown this, but we think that you can't make so many transformations as we make without having a syntactic representation, because it's gonna be a mess. Maybe you guys don't need to be convinced, but I think lots of other people do. And then lexical choice, word frequency is an important dimension. So for example, extroverts use more frequent words and introverts use infrequent lexical items, and you can calculate that automatically by looking at a corpus if you have a big enough one. You can also sometimes get that data out of lexical databases, whether a word is highly frequent in the language or not. And again, you can choose the closest synonym. And so when you put all this stuff together, like I said, there's 67 different parameters in personage right now. So you can see that we can produce, thousands of variations for a single input. What we want to do then is assess how we control all these parameters to do the different dramatic characterizations. So I'm going to talk about our evaluation experiments, although I'm only going to talk about one. So we have three methods. We have this rule-based method that's like that table I showed you in the beginning, where we kind of mine the psychology literature and we say, okay, for this parameter, it looks like an introvert should be at the low end of the scale and the extrovert should be at the high. So that's our rule-based method. We set these parameters with a standard deviation around a mean, so it's like 0.2 plus or minus 0.15, right? So that would be a parameter setting on the low end of the scale, and maybe 0.8 plus or minus 0.15 at the high end, right? So it's not a fixed thing. And also these parameters aren't independent, but we're going to pretend like they are later on. Then we have an overgenerate and rank method, which is kind of standard in statistical natural language generation, where you generate lots and lots of different alternatives. You collect ratings on those alternatives, and then you learn a ranking model. And we did that, but it's computationally expensive, and it has some other problems as well, which I'm not really going to have time to talk about. And our last method, which is published in our ACL 08 paper this year, so this is one of the first times I've talked about it, is a new statistical method that's a parameter estimation method, where we try to learn the parameter settings directly from the judges' ratings. And I'm going to show you some examples of that. So the computational advantage of this is that there's no overgeneration. We still have this random generation phase where we generate 160 random utterances, and we assume that we kind of turn this around backwards. So we generate these utterances using trying to use a uniform distribution over these parameters for the random generation, and then we get judges' ratings of how these utterances express different personality traits using a standard personality test. But then what we do is we kind of turn this around when we do the learning, where we try to predict the parameter setting from the input personality rating. So what we learn is a thing that says, I'll show you in a minute, actually. And then we learn a model for each parameter. We're assuming that the parameters are independent, which isn't true. And then we use a bunch of different machine learning methods, and we find which model using cross-validation is the best one. And then we generate utterances using that best model for each parameter, and then we've tested them with human subjects. So here's the kind of models that we learn, like say for the stuttering parameter, it learns that this is a model tree, a linear model tree. So basically it kind of partitions the data and then has a linear model at each leaf node. So what this says is, if your input conscientiousness value that you want to express is less than 3.875, then the value of the stuttering parameter is this linear function. So it's a function of the emotional stability value that you want to express, the conscientiousness value you want to express, and the openness to experience value that you want to express. So what this means is that for any scalar, so you have this vector of 5 personality traits. You can have any scalar value in there from 1 to 7, and you give that as input to the system, and for all of the 67 parameters, it'll calculate what the parameter setting should be for those parameters to express that combined personality trait. Does anybody have any? I have another one to show you. This is some of the parameters, as I said, are binary, and we've been really promiscuous. We've just thrown the whole Weka toolkit at this. So we've got different kinds of models for different parameters. So we have an AdaBoost binary classifier, for example, that predicts the exclamation parameter. And again, what you find in these learning, and this might possibly be a function of the amount of data we have. If we had more data, we might get richer models. But what you find is that particular personality traits affect particular parameters and some don't, right? And there also that there are multiple ways of expressing a particular personality trait, like the same, like a little bit less of one parameter could affect a little bit more of another, which is a way in which they're not independent, which at the moment we're kind of completely ignoring. But what you get with AdaBoost is that it says whether the parameter should be on or off, and what this mostly, and what it does is it accumulates the weights to affect the probability of the parameter being on or off. And what this shows is that, like, using the exclamation parameter is mostly a function of extroversion, although high agreeableness people do it too. So we ran a subject study with 24 judges that we solicited from the graduate student population at Sheffield. And so we tried to project, we have utterances that project two extreme traits. And so each utterance, there's two traits that it's trying to project an extreme on and three traits that it's trying to hit in the middle, right? So we wanted to maximize our data, and we couldn't do everything with a human subjects experiment. So we have these 24 judges rate 50 utterances, and what that means is they have to use this standard personality inventory, which consists of 10 questions. So this is answering, each subject basically answered 500 questions, 10 questions for each utterance. So we wanted to get something that subjects could complete in less than an hour, because otherwise you never get anybody to do your experiment. So even if you're paying them, they just won't do it. So what this shows, these numbers here, these tables, this is looking at the correlation between the projected extroversion value that we were trying to project and what was perceived. This is looking individually. This is the average across all 24 subjects. But if we take some of the noise out and we look at the mean perception of all 24 subjects, and then we look at the correlation, we get really much better numbers. But in each of these cases, these numbers are significantly better these are statistically significant correlations, except it didn't work for conscientiousness. And we don't know why that didn't work, because in our evaluation of our rule-based method, so one hypothesis would be, well, restaurant recommendations just aren't a vehicle for expressing conscientiousness. But that's not true, because in our rule-based method, we were able to get differences for conscientiousness, so we don't really know why that didn't come out. Now, I just have one, so this is like these are the rule-based numbers. And I'm missing one of what I wanted to show you on the rule-based. Okay, so here's a rule-based evaluation. So in that case, we're only trying to target the ends of the scales, and it works really well, right? You can see that when we tried to project something that was extroverted, it was really strongly perceived as extroverted, and introverted, it's really strongly perceived as introverted. And if you treated this like a binary classification problem and you split it here and said, how are we doing there, you get like 90% accuracy on classification. But for these randomly generated utterances, we get these normal distributions, right? So what we end up with is that we don't have any training material here. And the problem with just blending the rule-based data with this randomly generated data is that in the rule-based data, all the parameters that predict introversion all co-vary, because we set them all to kind of, and there's just a tiny bit of variation around this standard deviation, so they all co-vary, so you can't tell with the rule-based one which parameters are really affecting the user's perception. So what we need, which we don't have, we need a method, like an active learning method, so that we could sample this space somehow more intelligently. So what you really want to learn from is something more like a uniform distribution across here. And we haven't figured out how we can do that. So we need some kind of, I'm not sure, some kind of hybrid method where we instead of generating all these random things in a batch and then going off and getting the user's perceptions, that we kind of have a model that's more like we generate them one by one, we see what the perception is, and then we hypothesize that if we move this parameter this way, we're going to end up over in this part of the space, and then you test it again. And that might also have the benefit that you could train with less data if you got this uniform distribution instead of a normal one. You can see that we get much stronger perceptions in this rule-based method, and that these are more in the middle. And so, and possibly another issue is, I mean, obviously if we had, 10 times as much data with this normal distribution, we might be doing much better because we might end up with a lot more stuff down at that end. But what we'd like to look at is whether we can figure out a way to generate a uniform distribution there to learn from. So, I'm sorry, I really tried to make this shorter. So in terms of our research challenges, we tried to show that these, even though there were these very weak correlations in the literature, that we ended up getting a lot of utility out of mining that psychology literature, and that these parameters that we hypothesized should look to be at least one way of kind of realizing those findings. We weren't sure whether you could express personality in a kind of dialogue system or game application where you just have limited content, because we were thinking, well, a lot of personality expression has to do with what you choose to talk about, and we, the only thing that we really have a handle on for that in the restaurant recommendation area is positivity versus negativity, and you can imagine that there's a lot more different ways of organizing content than just by positive and negative. But at least, that one thing seems to be very powerful. And the other thing that we've done that's completely different from what anybody did in psychology is we have these single utterances, and we're trying to see if users can perceive personality from just a single utterance, and that also seemed to work. We didn't know whether that would work or whether you might have to have a whole dialogue interaction before you would perceive personality. And we haven't answered this question of what types of speech acts manifest personality, because we've only tested this one thing. So what we'd like to do is kind of extend this. We try to look at the effect of embodiment, which is something that people have looked at here. There's also data in the literature that says, for example, that the gestures for different personality types look different, or the way that they carry their body. And that prosody, we didn't really look at prosody. We have a text-to-speech engine, but we don't have one that we can manipulate. So if you listen to this from a standard text-to-speech, we think that we don't have a text-to-speech engine that we can get kind of that pitch range compression and stuff like that that we think you would need to really express introversion. Oh, this is wrong. This is the wrong clip. Okay. So we'd like to put this in an application. We think that the implementation is general enough that it shouldn't be too much to try it in a new domain, and we'd really like to try an extensive kind of dialogue application, like the kind of things that James has built here or that Michael has built, and see whether we could kind of marry those things and test some of these other effects that might only come out in an extended dialogue. So, any questions? James, you had your hand up first.
I have several questions about the Big Five, and how the first question came up sort of at the end, where you asked people to judge, and you showed on conscientiousness they had a hard time discriminating. Is there experimental data that shows that an average human subject is able to discriminate between these 5 different traits equally well, or are some of them more difficult to discern? And then the extension of that question is, does that vary according to culture, according to the personality the person has? So, for example, if I'm extremely introverted, almost everything might seem extroverted to me. or if I come from a culture where, you know, what constitutes extroversion in Japan is different from what constitutes extroversion in the United States. So
Yeah, there's cultural stuff. Most of the studies that we're drawing on are done on Western cultures. Although there's been some work, in fact, that James Lester is a co-author on a study where they looked at how politeness, which is kind of related to agreeableness, how that's expressed in American versus German speakers. You're an no? Well, it was done by that Johnson group. I thought you were a co-author on that paper. But anyway, they found that for some of this stuff it aligns, and for other ones it doesn't. And it's just that the data out there that we built on, so for the rule-based system, that would be a problem. But for the trained system, it wouldn't really be so much of a problem, because if you wanted something that was supposed to be a Japanese extrovert, you could just collect training data from Japanese native speakers. Although I do have to say that even though we have 67 parameters, obviously we can't generate every kind of variation that there is, you know. So, you know, we don't have and that part of the system. So given all these parameters that we have, a non-technical person could collect feedback and like press a button and get a generator that expressed particular character types for the kinds of variation that we have. But if you wanted a character to do something that we didn't have a parameter for, that requires a computational linguist to add that capability to the underlying generator. So maybe if we did it for a couple more domains, we'd have a rich enough set of stuff already in there that you could use it for quite a lot of different applications. But it could be that authors won't find it rich enough, because they want to have, you know, very unusual speech patterns or something like that. You know, like I was saying, like, you know, and also the other thing is that maybe a lot of the stuff that we've done are things that college students, the way that college students talk, because that's where a lot of the data's come from, is first-year psychology students, and so those are a lot of the findings that we built on. So it, you know, it's as general as we can make it, and we could put more stuff in, and you could train it for specific cultures or groups. Or somebody was asking me, like, if you wanted, you know, to model an individual person, or you had, you know, like a notion of orcness, you know, that you wanted, you know, would you be able to do it? And so you would be able to do it, right, just by having judgments of orcness with one of our training methods. But the question is whether the underlying generator generates things that are orky enough, right? So, James, did you?
So I wonder if you can speculate about how you could take the same approach, which seems like it's really effective for NLG, in broadness. So you sort of hinted at this for embodiment, but also for dialogue management. So, you know, initiative control and tendency to interrupt and things like that. How would you take this and then push it out into those domains?
I guess, I mean, it would be the same kind of, like the dialogue management. It's a different component, and the stuff about like taking the initiative. So probably what I would do is I would start off doing something similar, which is that I would do something rule-based, and then I would and see whether it kind of works if I just do something rule-based. And then I would try to figure out how to, using reinforcement learning or something like that, which of the parameters I was using to control the rule-based implementation were actually the ones that were having an effect in my particular domain, in my particular application. You could test this in a dialogue application without manipulating that initiative variable, obviously, right? But if you wanted to use it like in some of your stuff, like the embodiment, you'd have to test the consistency of the character expression between the linguistic style and the graphical. So in your embodiments, do you control those by parameter switching?
We have done a bunch of work like that really early on, but not in the current generation of stuff. And I think it's going to be really interesting to investigate that. So having this, if it's possible, sort of a uniform approach to doing language expression, dialogue management, gesture control, facial expression,
So how would you think
gaze.
the dialogue management would work?
I would come ask you.
Well, I don't know. I mean, so in your gesture, in your animation control, could you imagine you could have something like the bigness of the gesture, right? So it could just be there, or there, or there, or there, or it could be British, right? It could be, so you can imagine that being a parameter, but I don't know what all the parameters would be. I mean, obviously there's some kinds of things like how much fidget, there's like the autonomic nervous system kind of stuff, like, whether you're, doing this or not, and there's the size of the gesture, and there's the, what you're doing with your head, and I don't know, there's an awful lot of stuff going on there. There must be many more than 67 parameters. So it'd be interesting to see. And for me, for some reason, I really like this separation between this speech act layer and this stuff downstream, because then I don't have to worry about dialogue management. So I haven't really. I mean, I like saying, okay, that's you guys. You're doing the planning. You figure out how that's supposed to work. But the thing about the dialogue that's hard to evaluate is that, and so we use that reinforcement learning technique, for task-oriented dialogue systems, and it really limits how many different things you can vary, right? So because you need so much data, and I have a hard time believing that. See, this method that we use, which is kind of offline, like we show people a bunch of alternatives and we ask them to kind of compare them, listen to them and compare them. That kind of focuses in just on the variations that we're making at that point in the dialogue. And so we've done these experiments where we have a sequence of web pages where you kind of step through a dialogue, but we call that this overhearer strategy. So you could imagine you could do that for dialogue management as well, except that it explodes because there's too many paths. And what I don't know in terms of kind of collecting perceptual evaluations from human subjects, it seems like it really weakens this overhearer paradigm if you have an extended dialogue. It seems like in a dialogue situation, you want people, I mean, you could make the same argument here for language generation, but definitely I would think for dialogue, you don't want people to be doing metacognitive stuff at the same time that they're interacting, right? So even the idea like that you might have like a joystick that you're, going like, this is the dialogue's going really good at this point, and it's not, that just still seems like too much of an intrusion on participating in the dialogue. So I think it's just that much more complicated when you step up to that level and try to look at the effect of varying some parameter over the whole dialogue, just in terms of the amount of data you need and whether these training methods are better than just a good rule-based method. Yeah.
So there are interesting distinctions between real life and stories, and a lot of it is that the story is intentionally crafted and understood as being intentionally crafted to do something different than real life dialogue. And I wonder, taking these ideas and extending them into something that's specifically, say, narrative focused, would that step, where you bring in your data from real life, everyday life conversations, do you think it would maintain the validity of all the parameters, or would you want to collect data, say, from films, having people analyze dialogue in films instead, or is that even, do you think that even would be a distinction that would be?
Well, I think a lot of these variations that we have are ones that we're capturing a lot of the variation that you would see, I think, in film dialogues. Like if like Hedges how much hedging there is, and there's a lot of stuff, lexical frequency. There's a lot of stuff that where I think we're capturing some essential variation. But and I've had discussions with people, including some of the people that I talked to here yesterday, about whether you could estimate some of these parameters from a corpus. So if you had like a particular character's utterances over 10 seasons of a sitcom, you know, you might be able to do some kind of automatic analysis about their use of particular types of lexical items using the same kinds of tools that we use for doing personality recognition. You could get counts on a bunch of things, and you might be able to kind of model an individual character's speech patterns, assuming that you have the variation that you needed in the underlying generator. But yeah, I wouldn't think, so if the question is, do I think all of these ways of expressing personality, giving the restaurant recommendations, and the specific parameter settings would translate to you know, a narrative situation? I don't think so. I think you'd have to retrain. But 160 utterances, if that's enough, that's not that many. And one idea that we had was to kind of have an authoring tool. So, you know, for people that are really concerned about the author control issue, you could use this offline to generate a bunch of variants that they could then kind of say yes or no to. This is consistent with my character and this one's not. And then you could have, you'd end up with something that was like explicit paths through the story. Instead of having the generator actually in there, it would be kind of compiled, and in advance you'd have just a set of specific paths for the dialogue. But you could regenerate new versions of that all the time with different characterizations. And that might be kind of a middle ground where you have some kind of human-aided generation thing, you know, like it vets it, right? It says, oh, that's something that my character would never say anything that way. You got that wrong, and then you could just do it like that. Did that answer your question? You guys? No?
All right. Well, thank you very, very much,
Okay.
Lynn.